Hello everyone, welcome again to your wonderful, insightful section on your study part. Physics remains the subject, Mr. Femi remains the teacher. Today we'll continue in our series of Jamb revision for this particular year. And considering the last class, we stopped our topic revision on the topic refraction. We looked at refraction in the last class, of which we said we are going to be looking at calculations under this aspect. What are the likely ways for which you could be asked questions with regards to this part? So let's get right into it. So we'll look at the first calculation on refraction, which goes thus. So, given something as easy and simple as this in your JAMB examination, we want to put into use the formula we had from last week. And looking at it, we're given the speed of light in air, also given the speed of light in water. Don't forget, we made emphasis on the fact that whenever you're making reference to air and water in this case, you are working with the three states of matter. And we've identified the fact that all your three states are such that three substances would always account for them. Whenever we're making reference to solid, we have glass being used. Whenever we are making reference to liquid in physics, water is the best bet of what we use. And whenever we are talking about gases, we make reference to air. So from this question here, the formula we had last class is such that refractive index is always the speed of light in air over the speed of light in water. And why is this? We expect that refraction remains the process for which light travels from a less dense medium to a denser medium. From a less dense medium to a denser medium. Putting in our values. 3 times 10 raised to power 8 meters per second. No need, we can always finish up our calculation. Here we have 8 here. Cancelling out, this leaves us with 1.5 without any units. Now, a question as this. You should have it at the back of your mind that questions like this, once you are familiar with them before the examination, you would not necessarily have to calculate them in the exam. These are questions for which you see and pick. We call them see and pick. Why? 3 divided by 2. You know that the first value is just dividing the second value. You pick your values, divide them, sometimes with the use of calculator, and sometimes you're already familiar with what the answer is, and you are good to go. We take another question quickly. Okay. This is looking interesting. Here we have it. The figure below So we're asked to calculate the refractive index, and the diagram is such that we have our glass block, we have our normal, we have here being 60 degree, we have here being 90 degree, then we have here being 30 degree. Now, having something like this, as easy as it is, okay, we have an extension such that it is hitting the glass. Okay, there's no need for this. Hitting the glass and it is moving this way. So in this instance, we're asked to calculate the refractive index. But you agree with me that based on the question given, or based on the formulas we had before now, it is being itemized that we always pick values that are actually angles to the normal whenever we are calculating. It will be wrong for you to go ahead. Yes, you know the formula. The formula stipulates that we have refractive index according to... Is someone saying something? You can't see the board. Okay, my voice is also low. Okay, let me address that quickly. All right. A minute, please. The technical team will quickly look into that. Just a minute.
Can I hear you well, Abi?
Yes.
Can they hear you better?
Okay.
Sure.
So, how about now? Okay, you can see the wordings, you can't see the drawing. Okay, I can always make that enlarged. I can always make that enlarged. Okay, so something bigger. We have here, we are having this. Let's just make do because of the ear and ear. So, can you see the value here? Okay, beautiful. So let's just work with this here. We have 30 degree being given to us, and we have 60 degree here being given to us as well. So it's a question of the 30 degree is to the horizontal. Same way, the 60 degree is also to the horizontal. But the problem is this. Whenever we are calculating our refractive index, we always make do of angle to the normal, in the sense that the angle we need is the angle aligning with the vertical axis. The angle we need here is the angle associated with the vertical axis here. So our refracted angle is the angle to the horizontal, to the vertical. The incident angle is angle to the normal here as well. So for this question here now, it's expected of us to calculate angle to the normal. How do we go about it? We said that our I value would be 90 degree minus 30 degree, which gives us 60 degree for the value. Similarly, our refracted angle becomes 90 degree minus 60 degree, which gives us 30 degree. So you are not expected to use I as 30 and R as 60. The reason being that what? These are not angles to the vertical. They are angles to the horizontal. So here is what the diagram will now look like. When I'm to redraw the diagram, I would have, yes? I want to believe that that's network issue from your side, though. Are you sure it's not the network from you over at your end? You said? Can you take it again? There's a network glitch from your end. I can't hear you completely. Number one is what? You have two issues you want to address. You want me to address. The first is that okay, you just joined us. Okay, I get the point. Okay, follow us through. Possibly along the line, you can always flow with it. I'll try to recap on some of the things I actually did. But let me just quickly solve through with this question. Then I'll give it a recap for those that were not around. And for those that were around, a refresher of those formulas which we are going to be using. So here is it now. I would actually go over everything once I'm done with this question. So let's pick this question and call it, put it to an end. Now, here is it. We said that what? Anytime we are making reference to refractive index, we always consider angle to the vertical and angle to the vertical for the refraction side. So here now, I'm having an angle to the vertical now, which is 60 degree, and I'm having an angle to the horizontal here, to the vertical as well here, which is 30 degree. So this will serve as my angle I, incident angle. This will serve as my angle R, refracted angle. And we know that refractive index is simply sine I over sine R. Sine I over sine R. Sine I now being sine 60 degree divided by sine R being 30 degree. So working with this, we already know that what? Sine 60 degree is 0.8660, while sine 30 is 0.5. Pressing your calculator. So from this, when we divide, we have the final answer. As 1.732. So, for the sake of some of us that were not around in the previous class, I would actually I would create a run-through of some of the things we'll be needing to solve questions here. Now, here is it. For those of you that are around, I expect this to be like a walkover for you, a refresher course for you, so as to what? Be sure that what you have read, you actually what? Understood them. Now, here is it. We said under refraction, what are the key things you want to know, talking about your UTME examination? The first is for you to know that what? As far as refraction is concerned, the definition of refraction. You should know the definition of refraction. It is first on the list among things you need to know. What is the definition of refraction? Once you are done with identifying the definition of refraction, then the next is about understanding Snell's law. Snell's law. You want to understand what Snell's law entails. Why? It forms the basics of questions, the basis of formulas you are going to be using to solve refraction questions. The topic of refraction, Snell's law, holds certain formulas which you'll be needing in solving the question. Once you are familiar with the concept of Snell's law, the next thing you are going to be needing would be refraction in liquids. Refraction in liquids. And there you are going to be looking at real depth and apparent depth. Real depth, apparent depth. So what is the concept of real depth? What is the concept of apparent depth in relation to refractive index? Then finally, the last thing you'll be looking at would be refraction in solids. And the focus would be triangular glass prism. Triangular glass prism. So this forms the basis. These four aspects form the key basis of what you need to know under refraction. The definition of refraction, Snell's law, refraction in liquids, then refraction in solids. Everything you have inside your all-inclusive physics or your physics textbook, new school physics, or you talk about your Jamb pass question, is revolving around concepts under these aspects. So let's look at them one by one and have a review of them. The first is the definition of refraction. So many definitions that come through, but you must understand that what? Refraction is the process by which light wave would actually what? Move from a less dense medium to a denser medium. From a less dense medium to a denser medium. That is what refraction occurs, entails. And you should know that what? As far as refraction is concerned, know the difference between all the three states of matter. Because when you are drawing comparison between a less dense medium and a denser medium, you make use of the three states of matter. What are the three states of matter? We talk about solid, liquid, and gas. Oh, you've not written this. Hello? You said? Let me hear you. You said what? The lady actually saying, what's the issue? I didn't get that. Okay. That's what I want to do. I want to try to go over everything under refraction again. Then we have our questions in place. Are you getting it? So I'm trying to review everything from the start. Then we look at the questions now in full. Yes. So I'm going to go over everything again. It's no problem. I'm sure nobody is against that. Do we have anybody with a contrary opinion? Okay, beautiful. So let's kickstart. The lady is actually saying something, but you are not kind of audible enough. Okay, let's get started. So, here is it. First up, we have that refraction is the process in which light travels from a less dense medium to a denser medium. From a less dense medium to a denser medium. Then I said this. How do you know which one is the less dense medium for any given question you have? Consider the three states of matter. Talking about the states of matter, we have solid, we have liquid, and we have gas. In physics, these three states of matter, we have a representation for them. What we actually use to represent solids, what we use to represent liquids, and what we use for gas. For solid, we prefer to use glass as a representation of our solid. In the case of liquid, we use water. You said? Okay. Gas, we make do of air. So anytime Jamb will give you a question, it is going to be with reference to glass, water, or air. Glass, water, or air. Questions are actually what's coined around these three substances: glass, water, or air. They represent the three states of matter, which you already know from your what? Junior secondary school. Glass, water, or air. And here is it. For the word dense or denser, what is it representing? It only simply means something being heavy. In normal English words, we are making reference to something being heavy. So when you are saying, oh, dense medium, solid is denser than liquid, you are simply saying that what? Solid is heavier than liquid. When you are saying liquid is denser than gas, you are referring to the fact that what? Liquid is heavier than gas. As such, in comparison, whenever we are going to make reference to our less dense and our denser medium, what is expected of you to note is that what? They will pick any two substances